Sometimes we're given quadratic and exponential word problems, and they're very, very common types that occur more often than not. So when we're dealing with quadratic and exponential word problems, area tends to show up a lot. Area of a rectangle, area of a triangle, because when we have a variable and we multiply x by another x, we end up with the squared term, which is quadratic. For example, area of a rectangle, if the length of a rectangle is x inches and the width is 2 inches shorter than the length, the area can be represented by the equation a equals length times width, where length is x and width is 2 less than x. If we were to expand this out, we would see how area is equal to x squared minus 2x. Height versus time is another popular quadratic model. The height of a projectile is modeled by the function h of t, and we usually see a formula that looks very, very similar to this, where we have a negative coefficient, often 16, also sometimes negative 4. It's either 8 or 9, 4.9. And then we have a linear term and sometimes a constant term. And these actually have specific meanings that you don't necessarily need to know, but sometimes when you're interpreting some stuff, it helps. This first coefficient is acceleration due to gravity. And since gravity is pretty much the same everywhere on our planet, that value often ends up being the same thing because it's either measured in feet per second squared or meters per second squared. And so that leading coefficient often ends up being the same value. The second one, that is our initial velocity. So whenever you see a problem that talks about initial velocity, you'll notice that number's already in the equation. It's given to you. Now another value that's really important to understand is the initial height. That is our y-intercept. That is our starting point. The constant will always be the initial height. If there was no constant there, then what we would have is an initial height of 0. So let's look at how we can use quadratic models. The length of a rectangle is x inches, so length equals x, and the width is 4 inches shorter than the length. If the area of the rectangle is 32 square inches, what is the length and width of the rectangle? So area equals length times width. So if our area is 32, our length is x, and our width is x minus 4. Then we have a quadratic equation where 32 equals x squared minus 4x. If we write it in standard form, we have x squared minus 4x minus 32. Now this is a pretty easy quadratic to factor, but we could also use our quadratic formula to solve for x. So we have x minus 8 and x minus 4. So then we get two values. We get x minus 8 equals 0, where x equals 8. We also get x minus 4 equals 0, where x equals 4. So we have two possible values for x. Now remember that x represents our length, and so we need to make sure that we consider which is the correct value for the length. Well, if x was 8, my width is 4 inches less. So if I plug in this, if my length is 8, then my width is 4. If I try to use 4, if my length was 4, my width would be 4 less, which is 0, and that doesn't work. So we know that length has to be equal to 8 inches, and width has to be equal to 4. Here we have a function, h of t, models the height in meters of a soccer ball above the ground t seconds after being kicked. What does the number 0.5 represent in the function? Well, again, this is our y-intercept. The y-intercept is 0.5, which means that that is our starting height. So we would be looking for anything that references starting height. The initial height in meters of the soccer ball, that's it. The initial speed in meters per second of the soccer ball, well, that's actually what 7.7 is. 7.7 meters per second. 7.7 meters per second. That is the initial speed. The amount of time in seconds the ball remains airborne after the kick, well, that's actually going to be our x, or x-intercepts. That's the amount of time that it's in the air. And the amount of time in seconds it takes for the soccer ball to reach its maximum height, that is the vertex of our quadratic. And so these are some important values to know when you're trying to analyze a quadratic model, is what each part tells you. Vertex gives us maximum height, x-intercept tells us how long it was in the air, the initial speed is our constant term. The given function measures an object's height above ground t seconds after being launched straight up in the air. How many seconds after launch does the object fall back to the ground? So we want to know at what time is it on the ground. Well, on the ground, height equals 0. So we take h of t and we replace it with 0. And this is again how we find our x-intercepts. So we have a GCF, negative 16t. That just makes factoring and solving a little bit easier. We're left with t minus 4. Well, we can solve both of these factors. Negative 16t equals 0, t minus 4 equals 0. Well, this gives us time 0. That's where we started. And this gives us time 4, which means it took 4 seconds for it to return, fall back to the ground.